In this video, we'll answer this question: which has a greater effect on electrostatic force, charge or distance? And you recall from the last video that if we increase the charge right there, see it? We get more electrostatic force. If we increase the distance though, charge is the same, distance is greater, they're further apart. That's less electrostatic force. And of course it works the other way too. Less charge, less force. Less distance, more force. Alright, now in a minute we're going to use the formula for electrostatic force to see which is more powerful on it, charge or distance. But first I need to teach you a simple little substitution technique, and to do that I want to use an older formula and a simple one. Then we'll use that technique on the more complex formula. Alright, here's an old formula for work. Work equals force times distance. Now, let's say we ask this question. What happens to work if we double the distance? You'll probably use common sense and just say, well, if I double that, then work is doubled, right? You'll probably just say that. But here's a substitution you did in your head probably, and maybe didn't even notice. You had D here before. Now we're saying it's doubled. You probably in your head substituted 2D. See what we did? That goes there. It was D, now it's 2D. Now our formula looks like this, doesn't it? F times 2D. We're going to bring the 2 out front, and look, just as your intuition told you, work is doubled. But we're proving that via that substitution. Now you're going to use that in the more complex formula in a minute. Let's do another one though, another example. What happens to work if force and distance are doubled? Well, this time you're going to put 2F in for F, see? 2D in for D as we did before, and now you get 2F times 2D. Those two multiply to 4, don't they? So 4 comes out front, and we've quadrupled the work. We've done 4 times the work, because both were doubled. Now you see how the substitutions go here? It's pretty easy, isn't it? We're going to do that in a minute with a more complex formula. Alright, so here is that formula. Here is the formula for electrostatic force. It's over here. It's in your MCAS formula sheet. Now you can tell it's the right one because see those Q's right there? Are those there? Q is charge, isn't it? Right. The one above uses mass, doesn't it? Yeah, this one uses charge. And note on the bottom, distance. The distance between the charges is squared, isn't it? So here's our situation here, represented in that formula. Okay, now I want you to notice there's a constant out front. It's this ginormous number down here. Look at that. So it never changes. This is a constant. So we're gonna ignore it. It's always going to be there, but we're just going to ignore it because it never changes. Now here's your video code, ginormous. All right, so let's try now substituting into this more complex formula. First question is, here's a question: which has more effect on electrostatic force, doubling a charge or doubling distance? Let's first try doubling a charge, 1. We'll do Q1, okay? We'll say 2Q1 goes in there, there it is, and then the 2 can come out front. So, doubling a single charge, like this, ends up doubling the force, doesn't it? Let's see if the same thing happens for distance. Now we're going to double distance. So 2D is substituted for D. And note then, you got to square the whole 2D, don't you? Sure. That because D was squared before, now everything inside here, because 2D is substituted for it, it must be squared. So that becomes 4D squared, doesn't it? So look, doubling the distance has more of an impact. Doubling distance divide ES force by 4. Doubling a single charge double the force. Doubling the distance divides it by 4. The answer to this question is then distance has more of an impact. I'm going to skip this because we just said it and I'm running out of time. What if we double both of them? We doubled two charges and distance. That becomes 2Q and 2Q. That's 4 on top. This gets squared to 4 again. Look, it cancels. If you doubled everything, top and bottom, charges and distance, there would be no impact, would there? Okay, that's a summary for this one then. Let's see, the 2 things you should take for this video. Distance has more effect on ES force than does a single charge, and this substitution method. Because sometimes they ask you on the MCAS, how much change is there? Is it 3 times? Is it 4 times? To answer that kind of question, you should substitute like this and get your number, and that's how it works. All right, bye.